Part 1. A relatable introduction. Have you ever watched a movie about the future where people can enter a digital world like it is real? Not just looking at a screen, but actually feeling like they are inside it. A lot of people wonder if that is just fantasy, or if that kind of technology already exists today. And the truth is, it already exists. It is called virtual reality, or VR. The problem is, many people still think VR is just for gaming, even though its potential goes way beyond that. VR is not just a cool headset you wear. It is a mix of physics, computer science, psychology, and how the human brain understands reality. Behind a simple three-dimensional experience, there is a system working extremely fast and precise. Imagine you are standing at the edge of a virtual cliff. Your body knows it is not real, but your heart still races. Why does that happen? This is where VR becomes really interesting, because what is happening is not just on the screen, it is happening inside your brain. In this video, we will break it all down, from the basic concept to the advanced technology behind it. We will also explore how VR is used in real life, from entertainment to education and professional training. And by the end of this, you might see VR in a completely different way. Not just as entertainment, but as a bridge between the real and digital world. Part 2. A short history of VR. Before VR became popular like today, the idea already existed decades ago. Back in the 1960s, a scientist created a machine called Sensorama. This machine tried to combine visuals, sound, and even vibration to create an immersive experience. Even though it was still simple, it was the first step toward VR. Then in the 1980s and 90s, VR started being used for military and research. Pilots were trained using VR simulations so they could face dangerous situations safely. But at that time, the technology was still limited. The devices were big, expensive, and not realistic enough. Around the early 2010s, VR started growing fast again. Advancements in graphics, motion sensors, and high-resolution displays made it more realistic. Big tech companies began investing in VR. They saw massive potential in it. From there, VR entered the consumer market. Regular people could finally experience it. And today, VR is used in many industries, from gaming and movies to education and healthcare. This long journey shows one important thing. VR is not just a temporary trend. It is an evolution of how humans interact with technology. Part 3. The basic principle of how VR works. Now we get into the main question. How does VR actually work? At its core, VR works by tricking your brain, but in a very smart way. When you wear a VR headset, you are looking at a small screen in front of your eyes. This screen shows two slightly different images, one for your left eye and one for your right eye. This technique is called stereoscopic vision. It is the same way your eyes see the real world. Your brain combines these two images and creates a three-dimensional perception. VR also uses motion sensors. These sensors track your head and body movement. When you turn your head to the right, the image inside the headset updates instantly. Everything happens incredibly fast, almost with no delay at all. If there is even a small delay, your brain starts to feel uncomfortable. That is why VR needs to be very precise, because the human brain is sensitive to movement. On top of visuals, VR also uses spatial audio. Sound can come from specific directions. For example, a sound behind you will actually feel like it is behind you. All of these elements work together to create the illusion of being in another world. Part 4. The technology behind VR. Behind the simple experience, there are many technologies working together. First is the display. VR screens need very high resolution. If not, the image will look blurry or pixelated, and it breaks the immersion. Then there is the refresh rate. The higher it is, the smoother everything feels. VR usually needs at least 90 Hz to avoid motion sickness. Next is the tracking system. This tracks the position of your head and hands. There are two main types: Inside-out tracking and outside-in tracking. Inside-out uses cameras on the headset. Outside-in uses external sensors. There are also VR controllers. They let you interact with the virtual world. You can grab objects, press buttons, or even draw in the air. All of this data is processed by a computer or chip in a fraction of a second. This process is called rendering. It means generating images based on your position. The faster the rendering, the more realistic the experience becomes. And everything must stay in sync, or the experience will feel off. Part 5. Real-world use cases of VR. VR is not just for gaming. Many industries are already using it seriously. In healthcare, VR is used for surgical training. Doctors can practice without risking real patients. In education, students can explore history, as if they are actually there. Imagine learning about ancient Egypt while standing inside a pyramid virtually. In business, VR is used for virtual meetings. People can meet in a shared digital space. It feels more real than a regular video call. In real estate, VR is used for home tours. Buyers can explore houses without visiting them physically. Even in therapy, VR helps treat trauma, like phobias and anxiety disorders. Patients can face their fears gradually, in a safe and controlled environment. All of this shows one important thing. VR is more than entertainment. It is a tool that can change how we learn, work, and interact with each other. Part 6. Common mistakes and the future of VR. Many people think VR is already perfect, but there are still many challenges. One major issue is motion sickness. Some people feel dizzy when using VR. This happens because of a mismatch between what the eyes see and what the body feels. Another issue is the price. Not everyone can afford VR devices yet. Also, VR content is still limited. Not all industries have fully developed VR applications. But technology keeps evolving. In the future, VR will become lighter and more affordable. The visuals will get closer to real life. We might even see VR combined with AI, creating virtual worlds automatically. Imagine entering a world that is designed specifically for you, based on your imagination and your needs. At that point, the line between real and digital will become thinner. And the question will no longer be whether VR will grow or not, but how far we are willing to go with it. If you enjoy content like this, click subscribe and like to support this channel, and share it with your friends who might need this kind of help convince your brain that the environment is real. That is why interaction design is a huge part of VR development. Part 10. The difference between VR, AR, and MR. A lot of people confuse VR with other technologies, like AR and MR. Let's clear that up in a simple way. VR replaces your entire environment. You are fully inside a digital world. You cannot see the real world anymore. AR, or augmented reality, is different. It adds digital elements to the real world, like seeing virtual objects through your phone camera. MR, or mixed reality, goes one step further. It blends real and virtual objects together, so they can interact with each other. For example, a virtual ball bouncing on your real table. All three technologies are part of the same evolution, but VR is the most immersive, because it completely controls your perception. That is why VR is often used for deep experiences like simulations and training, while AR and MR are more common in daily practical use. Understanding this difference helps you see where VR truly stands. Part 11. The future possibilities of VR. Now let's imagine where this is going, because we are still just at the beginning. In the future, VR could become part of everyday life. Work meetings could happen in virtual offices, with realistic avatars and environments. Education could become fully immersive. Students exploring space or the ocean firsthand. Entertainment could evolve completely. Movies where you are part of the story, not just watching it. There is also the idea of the metaverse, a shared virtual space where people interact, living, working, and socializing digitally. Even shopping could change. products in virtual stores. All of this depends on how fast the technology improves. Better hardware, faster internet, smarter software. But one thing is clear. VR is not slowing down. It is moving toward becoming a new layer of reality itself. And when that happens, the way we experience the world might change forever. If you enjoy content like this, click subscribe and like to support this channel, and share it with your friends who might need this kind of insight. Part 7. How your brain gets fooled by VR. Now let's go deeper into something really interesting. Why does VR feel so real even when we know it is fake? The answer is, your brain does not see reality directly. It only interprets signals from your senses. Your eyes send visual information. Your ears send sound. Your body sends movement and balance signals. Your brain combines all of that and creates what you call reality. In VR, technology replaces those signals. It feeds your brain with artificial input. When done correctly, your brain cannot tell the difference easily. For example, when you look down in VR and see a high building below you, your brain reacts instantly. Even if logically you know you are safe, your heart rate increases. Your body becomes tense. This is called presence, the feeling of actually being there. Presence is the main goal of VR. The stronger it is, the more real it feels. Developers work hard to increase presence. They reduce delay, improve visuals, and enhance audio. Even small details matter, like shadows, lighting, and object movement, because your brain is very good at detecting things that feel unnatural. If something is slightly off, the illusion breaks immediately. That is why VR development is not just technical. It is also deeply psychological. Understanding how humans perceive reality is just as important as building the hardware. Part 8. The role of latency and why timing is everything. Let's talk about something most people never notice, but it is one of the most critical parts of VR. It is called latency, which means delay between your action and system response. When you move your head, the image must update instantly. If it takes too long, your brain notices something is wrong. Even a delay of a few milliseconds can make you feel uncomfortable. This discomfort can turn into dizziness, or what we call motion sickness. In real life, your movements and vision are perfectly synced. But in VR, this sync must be recreated artificially. That is why VR systems aim for ultra-low latency, usually under 20 milliseconds. To achieve this, devices use powerful processors and optimized software. They also predict your movement slightly ahead of time. This is called motion prediction. So before you even fully move your head, the system is already preparing the next frame. It is almost like the system is guessing your future. This level of precision is what makes VR smooth and keeps your brain comfortable. Without it, VR would feel unnatural and even unusable. Part 9. Interaction inside virtual worlds. Seeing is one thing, but interacting is what makes VR truly powerful. In VR, you are not just a viewer. You are a participant. Using controllers or hand tracking, you can interact with objects around you. You can pick things up, throw them, or manipulate them in real time. This creates a sense of control and makes the experience more immersive. For example, in a VR training simulation, a mechanic can practice fixing an engine, not by watching a video, but by actually doing the steps virtually. In education, students can perform virtual experiments. They can test things that would be dangerous or expensive in real life. This hands-on interaction improves understanding and memory, because learning by doing is much more effective than just watching. Even simple interactions like opening a door or pressing a button